Hello everybody, this is Professor H with another networking video. This time we are going through part 2 in the OSPF series, and this corresponds to chapter 6 in the packet guide to routing and switching. So without further ado, let's chat a little OSPF. As just a reminder, OSPF is what we call an interior routing protocol. That means you use it within a company or an organization. It is also link state, which means that it knows a little bit more about the network connections, the network around it, than, say, a distance vector. And what I really should say is that individual routers know a little bit more about the network around them, things like links, costs, stuff like that. So as we saw with RIP, what we do is routing table exchange. You learn stuff, you decide whether or not to add it to your routing table and send it to your neighbors. OSPF doesn't do that. It calculates what's called its state and then sends information about networks. Once the network has converged, all we send are hello packets. And routers can exchange capabilities and the type of information that they have as well. And then that hello packet is, well, they're not tiny, but they're not the same as the link state, and really it's just a status message that says, hey, things are still here. Things are still going on, no changes. Now, one thing we didn't talk about last time is that open shortest path first topologies are thought of as autonomous systems. That is, you deploy this routing protocol within an organization that has complete administrative control over the set of routers. And so we call that an autonomous system sort of organization. OSPF topologies are made up of areas. So you collect a bunch of routers together that you want to work together, and you organize them into an area. This makes OSPF hierarchical, which means that there are some routers that only understand their area, and there are some routers that understand more than one area, and those are called area border routers. So there's a couple of flavors of routers here that we're talking about. We have interior routers, we have border routers, and then we have backbone routers. Backbone routers and the backbone area is the special area 0. Now there's two ways to talk about area numbers. You can actually give them a straight up number. It's fun to say area 51. But we also have a dotted quad notation that we can use to identify the areas or talk about the areas. This was the small topology that we start the chapter with. And we can see it's very, very small. And we'll talk about the message exchange here. But as we can see that when we build the routing tables, the router number 1 there will have 2 directly connected routes, the 1 and the 2 net. Router number 2 will have 2 directly connected routes, the 2 and the 3 net. And then they'll have to learn about the farther away network via the other router, and we're using OSPF for that. But you can see the metric here is a 2. When we look at the brackets in that OSPF route, we see the 110 there. That's the administrative distance for OSPF, and that tells us that generally we consider OSPF learned routes to be superior to RIP. But the metric is a little strange. If this was a RIP topology, it would be a 1 because that destination is 1 hop away. But it's actually a 2. So what does that mean? Well, that indicates that we're not only taking into account hop count, but in this case the speed of the network. So that's why the value is 2. This particular case, we were a 100 megabit network, and so the metric was 1 hop away and a 1 for the speed of the network. And here were the messages, and this is a reminder, this was in the last video. We start off with hello messages, and the minute you understand that there's a network or a router that does OSPF next to you, you start this whole capabilities exchange. Here's my database, here's what I can do. Let's exchange link state information, and then we do some link state updates, and eventually, after we acknowledge the link state updates, we wind up in a stable topology or a converged topology, and we transition back to the hello messages. Now, I just wanted to point out, here is an OSPF packet, and this one's got a little bit higher metric, so we got a metric of 12. And all I did in this particular topology was I changed the speed to 10 megabit. And so what we see here is the increase in metric. We're no longer dealing with 2s, we're dealing with 12s. All right. Later on in this same chapter, we start to talk about larger topologies, more complex things, and a couple of additional areas. So in the middle, we've got area 0, and then on the left, we've got area 1, and on the right, we've got area 2. This particular routing table, so I've just pulled the routing table from one router, and that is that BR4, ABR1 in the top left of area 0. And if we take a look at the routing table, we can see that we've got a bunch of directly connected routes. And that's actually how we identify what router this is, which router has these directly connected routes. But then we can also see that we've got an awful lot of OSPF learned routes. In this particular case, the router is learning routes from 2 different areas. But then we also see, in the case of the 4net there, that this is an inter-area route. Also the 1, 2, 3 network. So if you identify where the 1, 2, 3, and 4 networks are, we can see that those are actually on the other side of this topology. So we actually have to cross an area to get there. So we learned this from another router that is talking to that particular area. So this becomes an inter-area route. So that's another idea to pack away in your brain. So you've got the different kinds of routers, and then you got the different kinds of OSPF routes. And just for fun, I grabbed one of the backbone routers here in this topology, and you can see how the routes change. We've got different set of directly connected routes, a different set of inter-area routes, and a different set of routes that we know as being those that we're communicating with. And that is to say, we're familiar with those 2 areas, and so we can pick up those routes directly. So this is a different router. We can see that how the routing table changes because we had a different router. Well, I think that'll do it for this week, and that'll finish up our OSPF discussion here. I hope you've enjoyed the videos. I hope you enjoyed the chapters. Remember, there's a lot more out at brucehartpence.com, and I keep adding stuff. Take a look at the other YouTube videos that we have out here. Thanks again for listening. Thanks again for watching, and may your packets always reach their destinations.